So in the previous video, we looked at an introduction through an example to understand how we're doing something different and to try to understand why we would want to do that, looking at our weight loss example. What we ended the last video with was talking about that we would want to do some type of hypothesis test to see if there are differences in our average weight loss between the groups. That's where this analysis of variance test is going to be used, and more specifically it's going to use something called an F. Now, just as a heads up, we have not discussed an F before. We have used Z's, we've used T's, for example, but F is going to be something new. So we will talk a little bit about what that is, but we will be focusing on StatCrunch doing most of the math here for us. So we're going to look through our 5 steps. If you remember when we've done a hypothesis test, the main steps that change are steps 1 and steps 3. So although we will talk about all of the steps, we're going to focus a lot on those 2 since those are our big changes. So first, let's refresh our memory of what it looked like when we had 2 independent samples. So when we had just 2 independent samples, what did our hypotheses look like? Our null hypothesis then was that our 2 population means were equal to each other. And with our alternative hypothesis, we could put any symbol between those 2 population means that we wanted to. Now, just for a moment, pretend that we use the not equal to as an option, saying that the null hypothesis or that the means are equal and the alternative is that the means are different from each other. So looking at how our first step is similar but different here is, first of all, we now have K groups. Remember, we're comparing 3 or more groups. So we could have 1, 2, 3, all the way up to as many as we want. So K would have to be at least 3, but it could also be more than 3. So here that null hypothesis is the same idea, is that all the means are the same. Now the alternative hypothesis does look very different than what we've seen before. We're actually not going to have any symbol showing up, and the reason is because now that we have more than 2 things, it's really hard to put some symbols here. Our alternative is just going to be that at least one of the means is different from the others. And of course, when I say that's at least one, things that are important about this is not being specific at all. It's no direction. It's kind of like that not equal to that we have above. So no direction is given. And it's not giving any specific groups. Right, so at least one being different. So all of them could be equal to each other, but just one of them could be different. All of them could be different from each other. So it's very vague. Right, so at least one is going to be very vague for us. And if we end up believing the alternative, we probably want to know, well, which ones are different, how many are different. That's going to kind of be a goal that we're going toward. Step 2 hasn't changed since the first day we did hypothesis testing. So it's still reject the null hypothesis and believe the alternative hypothesis when our p-value is less than our significance level of alpha. So that has not changed. Step 3 is our other big change. And keep in mind that these formulas are always on your formula sheet, as well as conditions. The first one is that we need independent random samples. As we discussed earlier in the first video, we will only be focusing on independent samples inside this set of notes. Our second condition is different from what we've seen before, not because of what it says, but because what it doesn't say. All the populations are normally distributed. We've seen that idea before. What's not there is or a sample size of at least 30. And that's intentionally left off because here sample size is not a condition. We actually need all populations to be normally distributed. So of course, how are we going to know that? We're going to either have graphs to look at to see if they seem symmetric and unimodal, or we could be told to assume that things are normally distributed. The third condition is similar but different to what we've seen before. We're still going to have this population standard deviation, now multiple of them, which are unknown. But we're also going to have to assume that they have the same standard deviation. Not just that it's unknown, but that they're equal to each other. And for this condition, there are ways to assess it, but in our class, we will just be assuming that this one is true. For our test statistic, this is where we're going to see a pretty big difference, as we're no longer using a Z or a T that we're used to. Instead, we're going to be using an F. We're going to let StatCrunch do this for us primarily, but I still want you to have an idea of what this is measuring. So first, mathematically from StatCrunch, it's going to be what we call MST over MSE, which stands for mean squared treatment. And mean squared error on the bottom. And really just remembering these is going to be helpful for when we're actually doing the calculation using our StatCrunch output. But the idea of what this is doing is it's going to be comparing things between groups, is the idea on the top, versus inside or within groups in the bottom. What I mean by that. Let's go and actually look at our data we had. So one thing we could look at, and I'll actually add it here on our graphs, is I'm actually going to put the mean on here so that you can see them as well. So what the top is going to be doing is really kind of comparing, well, how different are these means? In our data set, this was 0 pounds, almost 7 pounds, and a little bit less than 3 pounds. So those means are different. But also there's this overlap going on between these individuals and the groups. So another way of thinking about what we're doing here is we're kind of comparing the means across the two groups on top versus on the kind of taking into account on the bottom how individuals are. So we're going to be kind of measuring how different the means are, but taking into account how much overlap or how much spread is going on inside each of the individual groups. So that's just the idea of what's going on here. Let's talk about this through a picture here as well, so you can see how that spread should make a difference here for us. And I'm going to do this here with box plots. So in my first group, suppose my box plots look like this. So even though they're box plots, the mean and median here, since they're all symmetric, which if things are normally distributed, should be true as well. So if I look at where these means fall, and then I kind of look at how different the spreads are. So even though these means are very different, there's really not a ton of overlap in our groups there. Versus instead, if I take the idea here of the same means, and look at these, even though they might be similar in their distance here, there's a much larger spread or a much larger overlap. So even if the means are this exact same in both situations, how far spread out those groups are is going to make a difference to me to say, well, these do look actually very different, but these really don't look to have near as big of a difference as what's going on here. So that's what this F is trying to calculate, is kind of comparing not only where those means are, but looking at how spread out the groups are from that mean as well. It'll use that F to help us calculate a p-value. So probably something to understand about the F is the larger it is more evidence against the null, or to reject HO. Or in a sense, the larger the F is going to give me a smaller p-value. And again, this is just for understanding what's going on here. We're going to get that p-value from StatCrunch and then make our decision and make our interpretation there as well. So that's the understanding of these 5 steps. We'll do these 5 steps in our next video with our weight loss example.